Welcome to DESI ASTRO. In this Python tutorial on Astropy, our objective is to learn that how to mask a astronomical data cube, a spaxel, along your spectral axis. So here the masking refers to the process of your selectively ignoring or excluding for a specific spatial spaxel for a data cube. So where a masked pixel is not included in your photometry or spectroscopic measurement and analysis further. Okay, so now understand the masking process of the data cube. So here I have a Rubik's cube similar to the data cube having 3 axes. So it has a 4 rows, 4 column and 4 sets of rows and column. So similarly it can be your x, y and z axis, right? So now suppose we don't want to include this spaxel, okay, the upper right spaxel, okay. So now what we will do, we will be excluding this spaxel in our data cube. So what we are going to do, we are going to take this spaxel. So it spaxel has say number 0 rows and okay. So like in Python we would from 0 indexing, so 0 rows and the third column, and along z axis we want to mask this whole data points. Okay, so this is the masking of the spaxel along spectral axis mean. So like once you mask like one data, you can give an array and you can mask your region of interest. So you want to mask the center, you want to mask the edge and your upper and lower side of the data cube, right? So this may be useful when like you want to study the region of a galaxy in the center, or like you want to focus on the outskirt of the galaxy. So in this scenario it may be useful. So let's do it using Python coding. Alright, so before doing that I need to download my data cube from the CSS for manga website. So for that I'm not going to do this data cube downloading process again. So you can watch this tutorial given on the screen, and I have also attached this link in the description of this video. Okay, right. So now we will be reading our data cube first, and then we'll go to the masking technique, right? Let me import some libraries. So import libraries. So I can import Astropy. So from astropy.io import feeds. So this takes care of your handling your feeds file, reading and extracting data. Then you can import NumPy. So for NumPy as NP, so this takes care of numerical stuff and array. And then you can import Matplotlib for visualizing, right? So pyplot as PLT, right? Now we have done this much. Let's read the data cube. Okay, so read data cube. So you can type here cube equal to feeds.open, right? And you can give file name. So I have this file name same manga, right? And then you can get a cube information. So cube.info will give here file information, just data file information, right? Done it. So then you can see that your flux is in first HDU, right? and your wavelength is in the fourth MCQ, right? So let's do it. So I will extract my flux, okay, the flux data cube. So extract flux, okay, flux data cube, right? So you can type here, say flux equal to 5, okay, and 1. So 1 for your this, okay, this number dot data, okay. So you can see enough defined. So there should be a cube, okay. There should be cube, not 5, right? So here you can see that. And you can print your flux, try this, and you can also get the shape of the flux. So here you have. So here you have a x, y, and z. So here you have z, y, and x format. Okay. Now what I will be doing? I will be masking. So I will be masking data cube along full z axis or a spectral axis. Okay. So spectral axis for certain spaxel, okay, right? So let's do it. So for that I will, so yeah, okay, so I can define my xy spaxel, right? So you can define the array spaxel. So also to certain array, okay, certain array of xy spaxel, right? So for that you can define here x spaxel, right? Or just say x coordinate, and you can just see here in p dot random, right? Random dot rand int, right? And can also import here random module if you want. Just import here, import random number generations, right? And then you can give your bound from this, okay. So you can give say from 1 to 74, right? And you can give any digit, any number of your structure. So you want to do for like 50. Similarly, you can also give y coordinate equal to a little different. So you want to give 1 to 35, right? So this you got your array, right? So you got your array x and y as spaxel, right? So like 531 will be masked like that. Okay. So for that I will okay, so I've defined my the spaxel coordinates. Now I will mask, okay. So for masking, along full z axis, right? So you can type here your cube, okay. So your cube and the column for your whole z axis, and this is for your y, okay. This is for your y coordinates, right? This is for your x coordinate, okay. And you want to give some number, okay. So you can give 0 for the masking, 1 you can give, or I can give masking that in p dot, not a number value, right? What is the mistake? Q y coordinates. Or okay, just okay. So here should be your flux. Okay, not cube. Okay, so flux. Now it's fine. Okay, so now it's fine. Now check it. Okay, so now we have mask this whole z axis. Okay, like now you can also mask your like a certain your range. Say suppose my size is 6732, so you can give any range. Say suppose you want to go from 2000 to 3000. Okay, but I will mask along whole z axis, right? So now plot the plot the masking. Okay, so plot masking image. Okay, so type here plt dot image show, right? And you can give here your the masking image. Okay, or masked image, right? So type here plt dot figure, right? Plt dot figure, then type here plt dot image show, right? And then you can give here your flux. Okay, and then you can give here your whole z axis, or you want to like plot image at your in between this any number. Okay, so you want to go to along z equal to say 3200 index, right? And then give your spaxel, right? Run it. So here you can see that this the white dot represents the masked spaxel. Okay, so you can okay, so you can also yeah, so like you can also change the number. So you want to say 0, you can see this is my image, right? And you want to go to your 1. So in your like in your all spaxel, in your all wavelength, this has been masked. Okay, so you can also put here 100. See, I mean at each spectral axis, this has been masked. So like mask certain spaxel along your whole z axis. Okay, so you can also do the opposite one, that like how to keep only pixels value correspond to your x and y coordinate, and the rest of your cube is masked. Okay, so let's do the second part. So I will do here, I will okay, so masked whole cube and keep keep only given a spaxel along z axis. Okay, so for that I will first create a masked data cube, right? Data cube. So you can call here mask cube equal to np dot pull like function, and you can give your your flux values. Okay, so I will give my flux values. Okay, so I can define here a new flux data cube. So you can put flux 1 equal to cube, right? Cube 1 dot data similar to your flux value because it has been changed under the masking, so I cannot use that one, right? So, and you can give here box 1, and you can give this data cube as a every value as a not a number, right? So you can check it, what is my mask cube. So it's not a number, so like everything has been masked. And you can also check the shape, it should be matched with your earlier shape. Okay, shape is same. Now I will now I will I will do the masking. Okay, so now perform unmasking, right? So perform unmasking. So for that I will give here a mask cube, right? And then recall your all z axis, your y coordinate, your x coordinate equal to, and then uh, append uh, append your clock's data cube as your y coordinate and x coordinate, right? Now plot it. So now plot this unmasked image, right? So to that, type here plt dot im show and a mask cube, and you can give your same coordinate as your earlier. So now put here and type here plt dot figure and run it. What is the mistake? There's some mistake. I think we need to give a different coordinate system here. Okay, so what I'm going to do, I am to going to define a array, right? So I just copy this array and um, then I will paste here and call it 2 times of your x and y. Okay, so make it 30 35, right? Now it's fine. Now run this code. So here you can see that I have extracted only a certain spaxel, right? Longer data cube. So you can go to the 1000. See, like, I mean, at your, you can go to 2000. So at your each spectral axis, the same spaxel has been masked. Okay. So this is that here, like, you have only subtle spaxel masked and rest are unmasked. So in this part, we have extracted only unmasked spaxel and rest are masked. Okay, so this is the tutorial, and I hope you got the idea that how to mask a data cube along your whole spectral axis, right? And you can also uh, give your index along your grid axis to mask in a certain region. And in part 2 we have done unmasking from a masked full data cube. Okay, so this is how it is done. So you can see, if you click here, you can see there's some number. Okay, that number is something, and the rest of there is 00. This is how the unmasking is done. So thank you.